So the next problem I want to solve is, alien dictionary. Which is, categorized as, a hard problem in the Leetcode, and it is really hard problem, but now, since you know what is the topological sort, and you will see that it won't be hard for you guys. Okay, so let's go ahead and define the problem. What is the alien dictionary? So we have some words from an alien dictionary, and we don't know the order of alphabet in that dictionary, right? So let's say, but we found, assume that we found some words that are ordered based on the order of the alphabet in that dictionary. For example, I'm going to go over, let's say we have some words from an alien dictionary like this. Let's say I want to go over BA, BC, AC, and CAB. So let's say we have this, we don't know, we don't have any idea about what is the order of the letters in this alien dictionary, but we know that these words are sorted based on the order of the, that language. So let's go ahead and solve this manually first, and then we will detect how we can relate this to the topological sorts. So I know that this guy is before this, right? I know this is before this. B and B are equal. How can I extract based on these two guys? I know that A is before C, right? Because B are equal, when BA is prior to the BC, it means that C definitely is after A. Also, how about these two? B is, BC is before, AC. I can detect that B is before A. So, okay, I have another knowledge here. B is before A. And how about these two guys? The last two neighbors. As you can see, A, I can detect A is before C. So I will write A before C. So as you can see, we have some dependencies, right? The question scenario is totally different. But if you want to solve it, you see that you need to extract some dependencies. In the previous problem, we had dependencies, initially in an array. All right, now we have a scenario, we have a story. We have a story, and we need one more step to extract the dependencies. And now I detected, right? So, and actually based on this, I will write A to C, AC, B is before A, so I want to put this here, and AC. So this is the order of, this alien dictionary. It will be B, I have to return BAC. So this is, the answer for this problem. Actually, as you can see, if it is your first time you see this problem, since you learn, the topological sort first, it is really, tangible, and it's not really difficult. You need to only extract dependencies. And the interviews, yeah, go ahead.
For the last one, how is CAB satisfying BSc dictionary? So I didn't get that.
Oh, the last step, you mean?
Yeah, the CAB word, the word CAB. How is that according to the dictionary BSc?
Oh, okay. Yeah, this is a word, right? This is a word. It doesn't mean, let's say, let's give you an example. you know, in the, you know, it's, you know, the English dictionary, we know that A, B, C, D, E, F, right? This is, you know, our, you know, the order, right? But I can write F, we have, you know, let's say a fabric, a word, right? F is before A. We can have that one, right? But if you check the dictionary, you know, English dictionary, definitely you, but the order of words that are sorted in your dictionary is based on this order, okay? It doesn't mean at each word we have to follow the order of the, our, you know, the letters. Does it make sense?
Yes, yes. Okay, got it. Got it.
Yeah, you know, because, you know, right now we say BA is before BC. So yeah, it is word by, you shouldn't worry about the inside of each word. It can be anything. But the order of, you know, the order, the sorting of all of these are doing based on, you know, are done based on, you know, the original order of the language. Okay, so as you can see, you know, we have here in we detected, you know, based on each pair next to each other. So I need to do only one extra step. I have to detect the edges, sorry, you know, the dependencies or edges, and then I will call my topological sorts. We already wrote the topological sort here. Let's assume, you know, we have this function. So go ahead and, you know, only create, I need to write a function only one function to create my edges. Let's go ahead and do this. So how can I do this? You know, I have a list of words. I want to traverse over this. I need two indices, right? One here in the, I need two indices always. One of them is pointing I. Let me erase here. Oh, sorry. Let me rewrite this because I want to put the PDF of these guys also in the. How can I do this? I need two indices, you know, right? You know, one of them is in I, and the other one should be points the I plus 1. And how can I detect that, you know, A is before C? I need to start for both of these guys another index. I need another index, internal index of words. Let's say I want to write, you know, W as index. I will start in both of them one by one. You know, they should, you know, point at first, you know, W is pointing 0. I will check if they are equal. It doesn't give me any knowledge. I have to increase my index W. And the next step, my W will be here. And I will check A is not equal, so I can create an edge, which will be A to C, right? I can create a new edge. And that's it. We need, you know, one for loop over to traverse whole words. We need one, you know, for loop to traverse all of these guys. But we will start I from, you know, 0 to len minus 2 actually here, because when my index is here, I need to check with the next one. So I will go from 0 to len minus 2, my I, okay? This will be my top level for loop. And inside of these guys, when I is here and I plus 1 is here, I need another for loop traversing the words. And then I will create my edges. So let's go and do this here. Actually, I can, you know, create directly my graph based on this, or I can create my edges and call my topological sort algorithm, okay? But if you, let's say you have this problem in the inner view, I recommend you to create, or maybe it is more reasonable to create for each edge, create your graph, because you have edge, you can create your graph, right? But also you can create all of your edges and call your topological sorts algorithm. So let's go and create our graph, and then I create our edges. Also, I will create, the graph directly to see, there is no difference in the algorithm. So I want to go over for, let's say, I in range 0 to will be len of words -1. And we know that in Python, this is not inclusive. It means that it goes from 0 to len -2, which will be this one, because if you want to go over I+1 always, you should be really careful about your indices. And we have these guys, and we have two words, right? W1 and W2 will be words I, and the word 2 will be words I+1. Okay, we put, both of these guys in W1 and W2 to make code more cleaner. Now I want to go over these guys, traverse, over, these two words. What will be the range of my for loop here? I want to write, for J in, I shouldn't be out of range, right? So let's say, for example here, W1 is AC, W2 is CAB. And I shouldn't go over, my index, or my J shouldn't go over, 0, 1. It shouldn't be 2, because we don't have 2 for this one. So that's why I have to put the minimum of the length of W1 and W2. The range should not be more than that. So I will go over 0 and minimum of length of W1 and length of W2. And that's it, right? So we go from 0 to the shorter word. And here we will say what will be the parents. So let's say I want to write parent will be, and we have a child. So parent is W1 of J. And child is W2 of J. I'm naming these namings, will make your code really clean. And I strongly recommend, get rid of all the indices by putting them in some local variables, because your code will be much more readable, and it is really important in the interviews. Only the solving the problem is not really important. If you name your variables really meaningful, and you do really clean code, they are they show that you are really you have enough experience. If you know the solution, be a little you should be aware of your namings, and you're writing the clean code. So now we know that the parent and child is parent is a character, child also is a character. So we will say if they are not equal, we have to go to the next step, right? But if they are equal, we have a knowledge, and we have to extract it, right? We'll say if the parent is not equal to child, like here, A is not equal to C. So I need to create an edge A to C, right? So let's say I want to define here. Oh, let me move this guy here. Let me move this. Okay. So I need to define my edges, which is empty. Right now I will edges that's append. I want to append the pair. What will be the pair? Will be parent and child. So we are, adding, all of the edges here. But if it is not equal, we will do this, and we don't need to go forward. For example, here, in the first characters, A is not equal to C, right? W1 is AC, W2 is CAE. This is not equal. We create these edges, and we don't need to continue because we don't have any knowledge. We cannot extract any knowledge from the rest of the words. Only the first one, the first mismatch, will give us the knowledge. So if it is not equal, we have to break. Okay, we have to break. And this words, we extracted, the knowledge from, the word 1 and word 2 for index of I. And we will, when we write the break, this for loop will be finished, and then I will go to the next one. And at the end, we will return edges. Let's say I want to put all of these guys inside a function. Define extract, let's say dependencies. Dependencies, and what is the inputs? What are the inputs? The inputs are words. That's it. We have only words, and based on that, we can detect all of these guys. So we return this guy and all the edges, and now we can call, our, the topological sort based on these edges, right? If we call this function, the output will be the edges. Also, it's better to count the number of nodes, which is n, right? Because as you can see here, for our topological sorts, we have n as inputs. Now we created edges, and what is n? How we can detect, create, detect and count the number of letters. Any comments?
Sorry, what was the question?
So right now, we create, based on the words, we detect, we created edges, right? We created edges. Now I wanna call, after this, let's say I want to define, I want to define alien dictionary, right? Let me write this. And the input is words. And we call the function we wrote here, extract dependencies. And now we want to call the topological sorts, right? We want to return topological sort. What is the first input of topological sort is, the number of nodes. Now we have edges. What is n? I need to calculate n also, right? We didn't calculate in the extract dependencies. So how we can, calculate also the number of nodes? A number of letters, actually. Yeah.
Maybe each time we add an edge, we keep a counter.
Each time we add an edge, actually the number of edge is not helpful, right? We need number of nodes, actually, letters, we have redundant, if we count only the number of edges, right? Am I true or not? We'll say, we have, like this. Okay, maybe I'm wrong. So let me check this. So how many nodes we have, how many letters we have? 1, 2, 3, 4, 5. And how many edges we have. Based on edges, we cannot, can we,
Can we use
actually,
a set?
Yeah, set is the answer. Yeah. Set is, more, reliable, Actually here, let's say, here we have parent and child, right? Each parent and child we can add into the sets. If they are repetitive, because it is set, we don't have any problem, right? So let's say I'm updating this. Here, let's say, the letters. I want to write here the letters. We have edges and letters, which is a set. For each parent and child, we detect here, let me move this guy. We create the edges, so here we will write letters that add parent, and also both of them we have to add parent. Actually, I can add them, both of them, but I want to make it a little, simpler for all. I don't want to do all of the Python tricks. Okay, so here we will write, the letters that add also child. Usually in this kind of questions, you can assume that you have the number of nodes, right? The number of the letters. But we want to make this more general answer. So the letters right now has all the letters in this alien dictionary, right? But we need only the length of that. So that's why I want to return edges and length of letters. So if that's why when I'm calling this guy, it returns me edges and also n. Edges and n. The second item is n, and then I can call my topological sort. I already wrote it, and that's it. As you can see, alien dictionary has only one step, initial step before calling the topological sort. Another way you can do, to solve this, you can merge this code in topological sorts. Right now we create edges and then we call, the topological sort based on edges. But you can directly here, instead of, creating edge, you can create your graph. Because we don't need, the main purpose was, to create a graph, right? We can directly here, instead of writing a parent is not equal to child, we can, add child in the list of, the parents in the graph. And directly we can create a graph and then go ahead. I think in the interview, it is better to merge this with the, with the topological sort, because if you do this, it will be waste your time more than doing this merging this part inside of the topological sort. The only thing you need to do is to write this inside of topological sorts. Actually, not topological sort, but let me show you. Here, let's say I want to show you. We build the graph, right? We build the graph, but right now we don't have any edges. We can update the build graph function. That's just, everything will be fixed. You don't need to change all of these guys. Only you can update the build graph. And inside of the build graph here, you will use, you don't have edges. you will have this function inside of that, and then you will update in degree and graph. Does it make sense? If you need, I can write the code. I can update this guy to have the alien dictionary, which is more efficient. Any comment? Any?
So basically, are we saying that we can actually build a graph while we are traversing the words, and then so we don't have to actually build the graph again?
Yeah, exactly. Yeah, it is better. You know, let's say I wanna let me right now we have the top level here, right? And only the build graph will be changed. Let me write this here because I think it is better to update your build graph function than, you know, writing, you know, top level and calling the topological sorts. Okay, it is much more modular, but, you know, in terms of inner view, it is better to do this. So I will write, you know, define, you know, this, let's say, alien dictionary, and you have words, right? And let's say, first of all, you know, we can check, you know, the, because we writing exactly directly this function, I can write if it's better to check edge cases. If it is equal to 0, we have to return empty because we don't have any letters, right? And here we want to call this guy the build graph, but the input is not n and edges. The input is words, and that's it. Let me, I think, you know, I can change this, but I don't want to, you know, overwrite my writings. That's why. So here we will have, let's say, graph and edges. Sorry, no, not edges, the in degree. We want to build a graph, but the input is not n and edges. The input is words, and that's it. And all of the remaining part is exactly similar to, exactly equal, and it's not similar, you know, exactly copy pasting, you know, the part, top parts, right? Only we need to update this guy, and let's go and update the build graph. So my build graph will be like this. Build graph. I think I can use this guy. I wrote lots of things here, and I want to use this guy. There is no copy for this, unfortunately. Okay. I want to update my, you know, build graph. Okay. So I need to create edges. Also, I need to create in degree. Sorry, you know, not edges, you know. We have, you know, graph and the graph is, you know, these guys are, you know, really, you know, repetitive. I and empty for I in range n, right? And for n, we need to, let's say we want to go over, you know, the whole words, right? let's say we want to go over. Okay. Let me. I think, you know, in order to initialize the graph and in degree, we need to do some calculations, right? Because we don't know what is the number of letters. Actually, you know, the first solution I went through was really modular solution, but also I'm doing this because I know it is better to do in the interviews. The top level is exactly like the topological sorts, only to review, to make it more clear. But for build graph, we need to build based on the words. That's it. I'm doing it only, we are updating the build graph function, right? So, but you know, I don't know the end, so that's why I want to create an empty graph. Also in degree, I don't know how many nodes we have. Also, it is empty. So we will go over, you know, I want to count all, you know, the characters we have. I want to go over word in words. In a for loop, I want to go one by one for all words. Also, I want to go over for all the characters. Let's say character. Well, let me write it the letter. All the letter inside of the words. I want to go one by one, traverse all the characters of each, all of the words. If you have this, I will write in degree of letter, and which is a set, right? Hash map. It is hash map is so similar to, you know, the hash set. We have key value. If the letter is repetitive, it will be overwritten, right? In degree will be 0. Also, I wanna define the graph of that letter. So that letter, you know, I wanna know what's the dependencies of this guy, right? The initial value will be empty list. So instead of writing, let me show you here. Instead of writing these 2 lines, because we don't know the n right now in the new build graph, we need to do this for loop. 2 for loops, and we initialize all of them with 0 and empty. That's it. We want to only extract the letters. So we did the first part, and the second part will be actually I deleted it. I need to rewrite it. After we did this, now we have in degree and graph. We want to go over all of the rows for I in range 0 to len of words -1, because we said we want to go over, you know, the second to the last node. And you will have W1, W2 will be equal to words I and words I plus 1. And now we're going to go over, you know, the traverse, you know, these 2 words, character by character, and we use another index in range 0 to minimum of length of W1 and length of W2. We go over, you know, this, you know, all of them, and then we will say, let's say I'm gonna, we know that the parents will be the W1 at index of J, and child will be W2 at index of J. And after that, I will say if parent, it is equal, you know, actually I wrote this, you know, first, but I want to make it, you know, more clear for everyone. If it is not equal to child, it means we have a new knowledge and we have a dependency here. And I will write here the graph of parents, because we already, you know, initialize, you know, the graph. The parents, I will append child. right? Because the child is one of the, the adjacents of the parents. And also I will do the in degree of child should be increased by 1. And then I have to break, because we don't need to go over the end of the words. And we do this and we create all of these guys. At the end, we have to return graph and in degree. Okay, so that's it. Our code will be exactly like topological sorts, only the building the graph. For building graph, we need to do extra work. And that's it. And our ADN dictionary will be, it's done. And the solution is done. And what is the time complexity? This last part of our session. What's the time complexity for this question? Any comment? Let me check. What is here or not? Okay. Any comments? I think this is the last of session. Everyone is tired.
I mean, time complexity will be the same only v plus e, but the number of times e will come is the overlap between the words. So not sure how to express it.
Oh, beautiful, beautiful. Yeah, you pointed it exactly the important parts of the time complexity. Actually, this is exactly v plus e. But what is e? Because in the inputs, when we are talking about time complexity, we have to go over based on the inputs. Right now, our input for this problem is words, right? We don't have dependencies. We have to define this based on our inputs variables. V means the number of characters, and E is number of dependencies, right? And number of dependencies, what will be the let's say the worst case for number of dependencies? Let me check here, and here, we checked if we have any dependency between these two guys, we will create a dependency, right? One dependency here, one dependency here. What will be the maximum number of dependencies for an array of words? It will be order of n, right? If you have n words, at most we will have n minus 1 dependencies, right? 1, 2, and 3. We cannot, based on 2 neighbor words, we can only extract only 1 rule, right? And for these guys, we can detect 1 and for this. So it means that this will be actually E in the worst case is n, which n is number of words, right? And what is V? V is number of characters. In the same way, space also will be, will be order of V plus n. But n is number of, actually if you say V plus V, it will be true, but n is much more accurate because it is based on our inputs. It is a little high level variable because E is extracted based on n. And it is better to have the n in the time complexity. Okay, I think it's done. It's 8, and but please review. If even for the problems and you think you are really comfortable, you need to review. I saw lots of people, they say I know this, but in the interviews, when they see some, variants, some, simple variants of the problem, they actually they cannot, solve the problem because they didn't do enough review of the problem that, you are, you know them. Knowing, always I'm saying this, knowing is not enough. Being fluent is enough for, doing the interview.